Hi, we're the NASA Psyche Sample Containment Team, team number P18977. We are a multidisciplinary group of IT students currently studying in the Capstone College of Engineering.
Arizona State University, ASU, and NASA Jet Propulsion Laboratory, JPL, launched a joint orbiter mission to explore the metal-rich asteroid 16 Psyche, located in the asteroid belt between Mars and Jupiter. The Psyche mission successfully launched in October 2023, with a planned arrival to the asteroid in August 2029. The goals of this mission are to visually study the formation of terrestrial planets and determine the material properties of the asteroid. In a possible future mission, NASA JPL and ASU would like to collect samples from the surface of the asteroid and bring them back to Earth for further analysis. Our senior design project is centered around designing and manufacturing the proposed containment system for samples retrieved from 16 Psyche. This, combined with data collected during the current mission, would provide insight into how the Earth's core was formed.
The vision for this project was determined mostly by the team with some input from our RIT MSD guide and Arizona State University point of contact. The requirements provided by the customer were flexible, which allowed our team to create our own problem, solution, design, and testing plans based on research completed by the team. Although this gave us a rocky start, we were able to remedy issues in a timely manner, allowing us to fulfill our clients' needs with a functioning prototype. Some key objectives of our proposed containment system are to make sure that the samples cannot be contaminated by outside materials, ensure there is adequate space available for collection of multiple samples, demonstrate that our full system can withstand traveling on rough surfaces similar to those that would be found on the asteroid, and verify that the system can be operated with minimal physical human interaction.
Our proposed system design is a rotating design of a floating rotational subassembly attached to a base plate by a steel shaft. The samples will be deposited individually into 10 capsules drilled into the donut, each with their own clamp lid. They will be deposited by a separate sample collection system. The system uses stepper motors to actuate the capsule lids and rotate the subassembly to the next capsule once each sample is contained and ready for the return to Earth. The system controls are operated manually using a Python program run on a Teensy board and powered by an external battery. Extensive research into material selection was completed to select affordable materials within budget constraints for reliable comparison to standardized NASA materials in testing and prototyping. Thus, most of the materials used are various plastics, steel, aluminum, or 3D printed carbon fiber and nylon.
We constructed and executed testing plans to ensure that our design will satisfy the engineering requirements outlined at the beginning of the project. These include pressure testing to identify any weak parts in our lid or bottom seal, vibration testing to ensure robust design and assembly of components, and finally, electrical testing of the motors used to drive the gear train, as well as linear actuator for proper control and alignment.
Manufacturing, assembly, and testing is currently ongoing, and full functionality will be determined at a later date. Currently, our system is mechanically assembled and the electronic components are being added and tested. We expect the storage capsules to isolate the collected samples from the environment and each other, functioning controls to navigate to the desired capsule for sample collection and sealing, and a structural system that can withstand the asteroid surface. Visit us at Imagine RIT to see the final result.
We would like to thank these advisors and guides for all of their extensive help along the way. Thanks for watching.